All right, so this time we're going to simplify rational expressions, which means we're going to use all the stuff we already did to now simplify rational expressions, which really just means simplify fractions. Okay? All right, so our very first one, that bell work. What is the first thing I should probably do to make my life easier? All right, let's simplify the top. I like it. Good suggestion. So we're going to put that squared in. 4 squared, 16. X squared squared, x4. Y cubed squared. See, you guys are so smart. Now on the bottom, I could also do something because that square root x is kind of awkward. What should I do?
X alone.
X, and then we change the square root to 1/2. Do you remember that? Okay, because that'll make it easier. Now the y, I can either move it up top or just leave it there. It doesn't matter. Now I need to simplify with the top and bottom. Okay? So what's 16 divided by 2?
Why does that X also have
It is 8. Sorry, what's your question, Sophia?
why does the X also have the exponent? The exponent wouldn't be for the one.
Here?
Yeah.
This is just on the x. That's why it would, if we wanted it on both, it would go all the way to here. So it's only on the x, and then the y is only -1. Okay? Now for x, this is where it's a little bit trickier. What's 4 minus 1/2? Anyone know?
3.5.
And what is that as a fraction? You're right. What'd you say? I just didn't hear you. He's giving up. Nobody? All right, well, let's do it. 4, 7/2. Exactly. Let's show everyone how we got there. So 4 is over 1. So in order to make it over 2, because we need a common denominator, I'm going to multiply it by 2 and get 8/2. Okay? And so now I have 8 minus 1, and I get 7/2, yeah? Does that make sense to everybody? Do you remember doing that previously? Yes. Good. All right, so that's going to be x to the 7/2. This one's a little tricky too, but easier because it's no fraction. 6 minus -1. I heard somebody, yeah, there we go. Good, I heard 2 people say it. Awesome, 7. Look how smart we are. Look at us go, right? You guys are all dead. You're just like, no emotion. All right. So what we're going to do now is we're going to simplify them. So the first thing we need to do is, if there is not a common denominator, we're going to need to get one. Luckily, all of these ones have common denominators. So 2/5 plus 3/5 is going to give us what?
1.
Yeah, because we're going to get 5/5, and somebody's already ahead of us to get 1. Perfect. Love it. Amazing. All right. X/5 plus 2/5. So they already have a common denominator. Can I do anything with x plus 2, or do I just have to write x plus 2? Now here's where it gets a little bit weird, and I'm going to preface this by saying you will not normally do this kind of thing. However, I need you to get comfortable with it right now, because later when we learn derivatives, you have to do it. Okay? So that's why this next step is going to be kind of weird. Because if you look here, it says polynomial-like with no denominator. So first of all, what does polynomial-like mean? It just means like a polynomial, but it can have negative or fractional exponents. That's all polynomial-like means, right? Because normally a polynomial can have like 1/2, or it can have -3 as an exponent. So I need to get rid of the denominator. So I got to get rid of the 5. How do I move the 5 to the top? Kind of. That's how I would do it like originally, like that's how we've done before, but then we would need an equal sign to do it that way. Cross the line. Flip the sign. What's the sign on this exponent? It's 1 and it's positive. So what I can do is put it up top and say it's -1. Right? Would you agree that's the same thing? 5 to the -1 is 1/5. Okay, good. And then x plus 2. Okay? Now, we don't technically have it looking like a polynomial yet, because we would need to distribute it in. Okay? So that means I'm going to get 5 to the -1 x plus, and this is where it's tricky, be very careful, I cannot combine 2 times 5 to the -1. So I have to just literally write them both out. Why can I not combine them? Because this is really 2/5. And if I combine them and say 10 to the -1, that's not the same thing, right? So for now, I need to just leave it like that, which I understand is weird. It's very weird. We're usually going to do it with exponents, and that's where we're headed. So, next one, we love the next one because what happens to the x's?
They cancel.
Yep,
It's just two.
just 2. Can I cancel out the x's in D?
No.
Not at all, right? Don't kill kittens. That's the poster on the wall. Okay. The reason is I would need an x here as well to cancel it out everywhere. So I can't do that. So instead, I'm going to write it as x to the negative 1 times 3x minus 1. And now, just like the previous ones, I'm going to distribute. So what is x to the negative 1 times 3x? How good are we?
3x squared. Wow. No, just 3x.
3x minus 1.
We're all like thinking about it, which is good. So let's work it out step by step. 1 times 3 would be just 3. Now remember, what do we do when we have x times x? What do we do with the exponents? Add them. What's negative 1 plus 1? 0. So do I have any x? No, right? Because x to the 0 is just 1, so I can ignore it. It makes sense too if you think about it, it would be x over x, which would cancel, right? Okay, now the next one, there's no x's, which means that I literally just write out the x, like whatever it is that's out front, right? It's just 1 times that. So there we go. This is my polynomial-like expression, okay? Next one, can I cancel anything out?
No.
No. So I got to do the same thing. I got to put that x up top. X to the negative 2 times 2x minus 6. And now we're going to do the same kind of thing we did before. 1 times 2 is just 2. X to the negative 2 times x to the 1, because if there's nothing there, there's a 1.
So this one.
There is. There's 1x, and it's negative because it's negative 2 plus 1. Does that make sense to everyone? Yeah? Perfect. And then, of course, there's no x's here, so we just literally write it out. Negative 6, x to the negative 2, right? There's nothing simplifies there. We just put them together. And there we go. That is our polynomial-like expression. Okay? Last one. This one's trickiest. What do I do with that square root of x?
1.
Yes, so it's going to be x to the negative 1/2 so that I can put it up top. Then I'm going to go 2x cubed plus 3x. Then I'm going to plug it in just like we did before with the distribution. So it's going to be 2. What is 3 minus 1/2 or 3 plus negative 1/2? Yeah, 5/2, right? It'd be 2.5, which is the same as 5/2. If you're having a really hard time, guys, put it as a decimal and put it in your calculator and tell it to fraction it, okay? All calculators will turn it into a fraction for you if you ask them to. All right, and then 3 times 1 is just 3. X times x to the negative 1/2. X to the, what's 1 minus 1/2? Yeah, x to the 1/2, exactly, Sophia. Good. Look at that. The rest of you, you're all sitting there going, thank God for Sophia and Cyan. Right? Has anybody answered that besides those two yet? I don't think so. Did you answer? No? No one else? Okay, all right. Well, here we go. Now we've got 2 that you guys can practice. So I'm going to pause the video, let you guys give those a try. These are what your answers should have been. So take a look at them and then we'll go through them real quick. Okay? I'm hoping you're all good with at least getting rid of the fraction and writing it this way, right?
I don't know why it's 7 times.
Okay, we'll take a look at that one. So here, negative
I
3
don't know.
plus 1, we got the negative 2, and then there's nothing, so we just write it out. On this one, it's a little bit trickier. So this was the same one we did before, where it was 4 minus 1/2, which gave us 8/2 minus 1/2, and that's where we got our 7/2 from. Okay? Now this one was the same, we did this one before too, I think, right? So 1 minus 0.5 is positive 0.5. Careful with that. A lot of people wrote negative 0.5. Okay? Awesome. Guys, that's it.
Wait.
What am I waiting for? I know I'm waiting for Alicia. I'm saying, what? What? Not. Did you just call her a what, actually? I said, what are you waiting for? You pointed at Alicia. That would be a who, Matthias. Who am I waiting? Oh shit, that's on the YouTube. All right, I don't know why I was doing that. So we cannot cancel those x's. So in this case, the only way to move that x to the top is the same way I moved the 5 earlier. X to the negative 1. And then I can write 3x minus 1. Like that. Okay? Now, if I wanted to, I could also distribute it, which in this case, it's a little bit easier, but it doesn't really matter to me because we're just trying to make sure we get into the habit of writing it like this, right? Writing polynomial-like expressions. So, because it's just to get us comfortable with it, so if I were to put it in, boys, hang on, Tomas, hold on. Pablo,
On number C, why did it cancel, but in this one no?
because we can't cancel it here because it's not, the x is not in everything on the top. It's not a common factor. Here it was in everything in the top and bottom. So guys, if I put this in, what happens? What happens to x to the negative 1 times 3x?
3x.
It would just be 3, right? Because what would I do? I would add the exponents. What's negative 1 plus 1?
2.
So it's gone, right? Now on the next one, it's not going to be gone. So it's going to stay there because we're just multiplying by 1. Do I need to write this first 1 here?
No.
No. So if you want to, you can absolutely write it like that. Excellent. All right, next one. Can I cancel anything?
No.
No, because it's not in everything, right? There's no x in this second part of the numerator. I know it's tricky, guys. So once again, I'm going to write it as negative 2 so that I can move it to the top. And then I'm going to distribute it in. So x to the negative 2 times 2x. So I'm going to go negative 2 plus 1, right? Because there's a 1 here. What would that become? Negative 1, exactly. And then on the next one, I can't simplify it. There's no extra x's, so it still just says x negative 2. Now, you'll notice we called these polynomial-like because, well, I can't actually, like a polynomial can't have a negative. Does that make sense? Okay, but it looks like a polynomial just has negative exponents. It's going to be really helpful in the next unit. That's why we're doing it, because you're going to need to be able to do this. Okay. Now this one, I actually can do some simplification here, right? So probably it's easier for us to bring it up to the top first, but you are going to see that this one actually just cancels out nicely. Because now when I put it in, what's negative 1/2 plus 3? Yeah, no, bigger. So 3